Hello, everyone. Thank you for joining today's live training. My name is Reese, and I'm going to be your moderator today. We're going to kick off today's session in a couple of minutes. We're just waiting so everyone has a chance to join. In the meanwhile, though, we'd love to hear from you. So let us know where you're joining from using the comments or the chat, depending on which platform you're watching on. And yeah, tell us something you'd like to learn from today's webinar. Just a quick note, we are using DataCamp Workspace in the session today. So if you don't have an account yet, please go ahead and make one. Hello, everyone, and thank you for joining today's live training. My name is Reese, and I'm going to be your moderator for today's session. We're going to kick off in about a minute or so. We're just waiting so everyone has the chance to join. In the meanwhile, though, let us know where you're joining from using the chat or the comments. And yeah, tell us something you'd like to get out of today's webinar. Just a quick note, the session is being recorded and the recording will be made available to everyone that registered for the event, as well as it will be able it'll be available for rewatch on whatever platform you're watching on, namely LinkedIn and YouTube are the main places to go watch it. Another note is we're going to be using DataCamp Workspace today. So if you don't have an account already, please create one, and you can head to datacamp.com/workspace to create that. I'll also be sharing a link to our workspace that you can copy, so you can code along with us today. Hello, everyone, and thank you for joining today's live training. My name is Reese, and I'm your moderator for today's session. We're going to kick off in about 15-20 seconds or so. We've just been waiting so everyone has a chance to join. In the meanwhile, let us know where you're joining from using the questions or the comments or the chat. And yeah, tell us something you'd like to learn in today's webinar. We are going to be using DataCamp Workspace in today's session. So if you don't have an account already, please sign up for one at datacamp.com/workspace. Pretty soon, I will be sharing a link so that you can code along with us. I think that's about everything from me today. I'll now hand you over to your host for today's session, Richie Cotton. Richie, please take it away.
Hi there, data scamps and data champs. This is Richie. Now, large language models are amazing, but the real AI gold rush this year has been about building generative AI into products. And ChatGPT is perhaps the most obvious example, but there are thousands of other cases where AI has been built into a product to improve that product. And LangChain has emerged as the de facto standard tool for building generative AI applications. And on top of this, the other technology that every data professional needs to get to grips with is a vector database. So vector databases are designed specifically for analyzing large amounts of text data. And so today you're going to be building a simple AI application with LangChain, with GPT, and with the Chroma vector database. So there's going to be lots of cutting edge technology involved today. And guiding you through all this is Emmanuel Pyr. He's a senior software engineer here at DataCamp. And Emmanuel is really DataCamp's go-to AI expert. And he's been involved in the creation of a lot of the AI features that DataCamp is rolling out this year. So really, he's at the cutting edge. He's the person to speak to. He knows more about this than almost anyone else. And so I'm going to leave you in his capable hands.
All right. Hi, everyone, and welcome. So today we are going to be building an AI application with LangChain and GPT. There is a lot to cover, so let's dive right in. So today we are going to make a chatbot app, a simple one powered by GPT 3.5. So that's the same technology behind ChatGPT. And we are going to make it so that it can answer questions about something that ChatGPT does not know about LangChain itself. So we want to teach new things to GPT. So we are going to get you set up with an OpenAI developer account, as you will need to make API calls to OpenAI if you want to code along. We'll install the LangChain package, prepare the data that we are going to ingest somehow, embed, use the OpenAI embedding API. We'll explain what it is, and we'll also get see how to get an estimate of how much it's going to cost. And all of these embeddings will be stored in a vector database. We'll see how to query a vector database, and finally put it all together into an application where we can talk to the LangChain docs. All right, so if you want to code along, first make sure that you have an OpenAI account. So to get an OpenAI account, you have links in the workspace. You'll first go to the API sign-up page. In there, you'll want to log in if you have an account or create one. I'm going to log in. And once you're there, follow the link, the second link here, to the API keys page. We want to create an API key. Now, as you see, I have a few. You can create your new secret key here. Give it a name. I'm going to go with my key. And create a secret key. Now, it's very important that you save this key, as it's the only time you will see it. After that, you won't be able to see it anymore, so be sure to copy-paste it somewhere where you can find it. I'm going to delete this one because I don't want this key to be abused, and you've all seen it. All right, so now you have an API key. Hopefully you have a copy of it. The next thing you want to make sure is to have a payment method with OpenAI. As if you want to make requests to the API, you pay only for what you use. But if you're going to use it, you need to have a credit card on file. So for this, just follow this link to the payment methods page. And in there, it's pretty easy. Just click Add Payment Method, enter your card information, and click Submit. All right. Last step to prepare and be able to make requests to OpenAI is going to be to actually pass this key to LangChain. But because it is a secret key, we don't want to put it in the code. We want to put it in as an environment variable. To do this in Workspace, head on the left to the integrations. As you see, I have already one, but you are going to create an integration. The integration you want to create is environment variables. And here you want to create only one environment variable that you need to call OpenAI underscore API underscore key. And in the value, you are going to put your key that starts with SK. After that, click on Create. You can skip this step that shows you how to use it. Actually, LangChain is going to be reading this key by itself, so there is nothing else to do. And in the last step here, you want to choose Connect in order to connect this environment variable to your workspace. I'm going to close because I already have one connected. All right, if you didn't have time to follow this, you have all the screenshots and instructions in the workspace. And we are going to be talking a bit about theory before starting, so you get time to do this. All right. So let's dive in. First thing first, we want to install dependencies. obviously, we want to install LangChain. So in this Python cell, I'm going to go !pip install LangChain, and I'm going to choose a specific version. I'll explain why later. We also want to pip install Chroma DB. Chroma DB is going to be our vector database today. And we also want to pip install a package called TikToken. Come from OpenAI. We'll use this to count GPT tokens. All right, let's run this. Should take about 45 seconds if you're running this for the first time. The reason we are using a specific version here, it's because LangChain is very active, has a lot of releases, and sometimes they are not the most stable. So because this is a live coding, I prefer to be safe and use a version I'm sure is working. If you check the current version, they are already at 198. It should work with the latest version. I'm just not taking the chance right now. Okay. So it has completed. We have everything we need. A little word about LangChain. LangChain is a framework to build applications with language models. And what it is, it's mostly a bunch of building blocks to create such applications. You're going to have modules wrapping models. So calling the OpenAI APIs very easily, but also other LLMs. You have abstractions around prompts. So the prompt is the text that is sent to the LLM. You have things called memories, indexes. Indexes is what we are going to see today. They have chains, obviously, because they are called LangChain. We'll make one chain towards the end, so we'll see this. And they also have a whole section about agents, which is pretty hot topic, but unfortunately, we don't have time to cover that today. So we are going to be using some of these building blocks today. All right. So before we go into loading data, a bit of theory. And to illustrate, I'm going to use this Playground notebook here. In this Playground notebook, I'm going to clear the output. I have a bit of code prepared here. Don't bother about this code. Just know that the GPT function is going to send one prompt to GPT and print the result. That is all you need to know. So that's pretty much the interface you have in ChatGPT, talking to GPT 3.5. So something that GPT can do a lot of things, but one thing it does not know is about, for example, Slice City. Slice City is a pizza place near my house, very good pizzas. But if I ask to GPT, what pizzas can I get for less than €5 at Slice City? Just like that, we are going to get a response that may seem familiar. As an AI language model, I do not have access to current pricing information for Slice City. You can check their menu, blah, blah, blah. So if we would be making a chatbot for Slice City, this is not good. So how can we teach GPT about the menu of Slice City? You have two main ways. The first one would be fine-tuning. The fine-tuning is taking a base model and training it through a lot of examples. So an example is going to be a prompt plus the completion that you want it to produce. You will train it on hundreds or thousands of these pairs. And after that training, it should know more. It should have learned from these examples. The big problem with this method is that it takes a lot of time. It costs money. And the worst is when your data is going to change, you will need to retrain it all over again. So that's usually not the way to go. The other method to get GPT to know about things that it doesn't previously know is through a technique called Retrieval Augmented Generation, RAG. And that's what we're going to do today. It's much more simple. You will see it is deceptively simple, especially for this example. So if I wanted to answer this properly, I need to give it this data. And here I have the Slice City menu. There is a few pizza, a few sides. I'm just going to copy paste this. So it's formatted as Markdown. Markdown is a format that GPT understands pretty well. And I'm just going to paste it here in the prompt. We have the menu. And right after that, we have the same question that I had. Let's run this. And now the answer is much better. You can get the margarita pizza or the veggie supreme pizza. And indeed, they're both under €7. So that's perfect. We need to provide it with the information we retrieve.
Emmanuel, sorry to interrupt. Can you just increase the size of the text in your browser? Just a quick command plus. All right, super. Thank you.
All right. So yeah, we need to provide it with the information. There is no magic. In this case, we can provide it with all the information it needs. It's a short menu. But if you have, and you probably have data that is much larger than this, you will need another method. You will need to retrieve pieces of that data, pieces that relate to the question. So for example, here we're asking about pizza and prices. So if we had a very, very long menu, we want to get only the pizzas, for example. And we'll see how to do that in real world. Okay, so let's see how it works in a more realistic setup. RAG, Retrieval Augmented Generation, has two phases. The first phase is where you're going to embed your content. So you have your whole content library. You're going to slice it up into small documents that talk about one concept. Cutting them in slices is very dependent on your data. And then each of these pieces is going to be embedded. This is done through the OpenAI embedding endpoint. And what you get back when you embed some text, you get back a vector. A vector is a very long list of numbers that represents the meaning of the text. I'll provide a small explanation about this because I can't possibly dive into this topic. So imagine that these models have some sort of space to represent data ideas, and they are trained to make sense of these data. So they learn to make links between things that are related. And as a result, things that are similar are going to be roughly around the same space in their space. Their space is hundreds of dimensions. This is a 3-dimension example. In here, we have a cluster around food-related words, supply, product, food, foods, meat. And here we have one about school stuff, student, college, elementary, school. All of these are similar. They are close to each other. So spatially, they are also going to be close together. This is how semantic search is working. We are not going to be matching keywords. We are going to be looking at the proximity of meaning. So this is what we do when we embed our content library. For each piece, we get a vector. And we store that in a database that we could call an index. Then later, this is a step that you only do once. Unless your data changes, you are only going to be indexing things once. You do this before you bring your application to the world. And then this is when users use your application, use the chat or something. They're going to have a query, which is usually a question, just a sentence. We're going to embed this sentence the same way that we embedded the documents. So we also get back a vector. we'll call it the query vector. And with this vector, we can query our index. And when we do that, basically, the database is going to go through all vectors that it has and calculate the distance between the query vector and every vector that it has. And it will return those that are closest to the query vector. In theory, these should be texts that are semantically similar to the query vector. So it's kind of search on steroids. This thing is not going to match words, it's really going to match ideas. Once you have the vectors, you can retrieve the text that were used to create the vectors. And when you have these pieces of text, you have a good part of the answer. So you have text that relate to the question, and you can pass them in a final prompt to GPT, a prompt that is very similar to our pizza example. For example, here we say in the prompt, use the following pieces of context to answer the question at the end. And then we pass those pieces of context. So we really just include them in the prompt like we did with the menu. And after that, we put the question and we ask GPT to give a final answer. This is how it works in theory. All right, so let's go back to the code, see how we can do that with LangChain. So we're going to go back to our main notebook and scroll to the first task. So first, we need to load some data. We need to get the LangChain documentation. It's a website. It has many pages with content, code, and text. The first thing you want to do is to download this. So you can click this drawer here to see how we did obtain the data. It's a simple wget command. It is already available to you. Please do not execute the wget command here, because if we all do that, hundreds of people, we might put the site down. So we've already done that for you. In RTDocs are a few nested folders, and then you will find here all of the HTML files that make up the documentation of LangChain. So this first phase, we are just going to load the HTML files. We need to clean it up because HTML is very verbose and there is a lot of things that is not the essential information. We just want to keep the text. And to do that, we can use a document loader from LangChain. Going back to the LangChain documentation, under indexes, you will find document loaders. There are a bunch of them. You can load data and get them as documents that are usable by LangChain from a variety of sources. And for us, it is HTML, but most specifically at the lower left here, you can see it is a read the docs documentation. Read the docs is a framework to create documentation sites. And as a result, you get something that is always the same format. So there is a loader specifically to load these type of things. So we have already downloaded everything in the RTDocs. We can now use the read the docs loader. So let's go. From LangChain document loaders, we want to import read the docs loader. We want then to create this loader. So that's a read the docs loader. The first argument is going to be where our HTML files are located. So it's in this directory. And we also want to enable the HTML parser feature. So the HTML is removed, and we do this with features equal HTML.parser. And finally, load the data by calling loader.load. This is going to return documents, and we will store them in a variable called raw documents. Let's run this. And now we wait. It's going to take around 2 minutes to load all the HTML files, clean up the HTML, and return them as documents. In the meantime, maybe there is a question from the audience that we can answer.
Yeah, we got a couple of questions from the audience already. And the first question comes from Alex saying, why are we using the Chroma vector database rather than Pinecone?
That is a good question. So in LangChain, you will see in the vector stores that they provide a lot of abstraction for many vector database. Pinecone is, as far as I know, a hosted solution only, so you cannot run it inside of a notebook, not completely. You need their backend. And Chroma is much easier in that sense. We can run it in Python only, save the files locally. So it's much easier for a presentation like this one. But vector stores, there are many of them, especially lately. So you want to check them out because each of them have specific features that may fit your project better. Chroma, here we are using it as an example, but you could be using any other.
It just seemed like there's a lot of competition in the vector database space at the moment, so definitely worth trying out a few. There are going to be some more live trainings trying other vector databases coming this summer as well. All right, so next question comes from Sumit, and Sumit asks, do we have to generate embeddings on the whole corpus, so every bit of text, so that we can retrieve the answers?
Correct. You will need to embed all of the corpus that you are interested in, because basically, if you want pieces to end up here in the context that is given to GPT, it needs to come from the vector database. So it needs to come from these vectors. So yes, you will need to embed everything. The good news is the embedding endpoint is the cheapest one that OpenAI has, as far as I know. So usually it's not that big of a cost, and it's a one time. You do it only once, unless your data changes, and then you would be re-embedding only the things that have changed. So it's usually not a big deal to have to embed everything.
Okay, I actually have a related question to this. So when you're embedding things, would you have like one line of text embedded at a time? How do you break it down when you're embedding your corpus?
That's a very good question, and that brings us to task 2, slicing the document into smaller chunks.
All right, let's move on then.
It really depends. It really depends on your data, as always. Sometimes it may make sense to have, if it's a long document, each paragraph to be a separate embedding. Some things are more straightforward. If you want to be automating a QA section, you have on your site a big QA section, you want a chatbot to answer these. Typically, you would be embedding one question and one answer as one document, as one unit. It really depends on your data. And you will have to make some tries, see what works best. Basically, you need to put yourself in the shoes of GPT. GPT is going to get pieces of knowledge here, and you have to find out what makes most sense for your data.
Okay.
In our case, we are going to use the most simple approach to that. We are going to use a text splitter from LangChain. So LangChain also has tools to do this. In here, in indexes text splitters, you will see a few. We are going to use this one, the recursive character text splitter. It is a text splitter that is generic, that works fine enough for at least to get started, to see where you are going with your data. And for us, it's simple enough that we can use it. What it does is it tries to keep paragraphs and sentences together as much as possible. It's going to go through the text and split first on double lines, so that's typically going to be paragraphs. If it's still too long, it's going to split on single new line. If it's still too long, it's going to split on spaces, etc., until it reaches the required length. So let's see how it works. We are going to import it from LangChain. So from LangChain text splitter, we import the recursive character text splitter. We are going to create this splitter object by calling the function. And we want to pass two parameters here. The first one is chunk size. So that is how long in characters. How long in characters do we want the pieces to be? We're going to go with 1000. It's a completely arbitrary value. Again, your experience with your own data, it may change. Don't think that this is the magic number. Next, we're going to give it a text overlap, a chunk overlap. Chunk overlap, I have an illustration of what it does. If we were cutting text without overlap, we would be cutting text and start the next piece when the previous stops. With overlap, we are going to have overlap over these pieces. And the idea is to try and retain context as much as possible. Again, it is not a silver bullet. There is usually better ways to slice your data because you will know your data. You will know where things kind of start and end. You want to have pieces that is a semantic unit that is talking about a single concept, because again, in the end, it will end up in a prompt, and the less you confuse GPT, the better it's going to be at answering the question. So we have our splitter that is configured this way, and last is to actually split the document. So we are going to call split documents because we already have documents, and our documents are called raw documents. Out of this, we are going to get documents again. Run this. All right, we have documents. Let's actually take a look at these documents. First of all, how many do we have? How many raw documents did we have? We had 1,000, let's say 1,000. And how many documents now do we have? So the raw documents were one HTML file equals one document. And now these documents are splitted into small chunks of 1,000 character. We get 7,000 of them. And so just so that you have an idea how they look, this is the first one. It's a document object. They have two attributes that we care about. Page content, that is the text of the document. And then there is some metadata. In metadata, you're going to get the source. So you know where this piece of text comes from. It can be pretty important, especially if you want your bot to cite its sources. So it's nice to have an answer, but it's even better to be able to link to the actual source material. All right, so now we have 8,000 documents. We're ready to embed them. The question is, how much is it going to cost? Because it may seem like a lot, 8,000 documents. First, let's go see the price. OpenAI has a pricing page with all its models. We are going to scroll to the embedding models. This is what we are using. This is not GPT, the chat GPT that you are used to that is going to do the embedding. It's a model called ADA v2 that we're going to use. And it has a very soft price of 0.0004 per 1,000 tokens. So that is how you find out how much it costs. So now it says per token. What is a token? A good page to get an idea of that is, again, a page from OpenAI. It's their tokenizer. So if you take a piece of text, any text, put it here, you will see how it breaks down into tokens. Tokens are not man-made. They have been made by GPT as it learns. The more it's going to see a word, the more chance that word has to become an actual token. So for example, some long words sometimes is a single token, and sometimes you have very short tokens like PT is a token. As you see here, most words are 1 token long. It really depends on the word. If you go with something that is a bit less, that appears less in the whole corpus of text that it has seen, for example, data camp. Data camp, as you see, is broken down into a token that is space D, then AT, then AC, then AMP. So these are the tokens. In the end, these are the same tokens. Every token just has a number, and this is the only thing that GPT deals with. It gets a list of numbers and predicts what is following, and it will also return a list of tokens that you can translate back into words, of course. So going back to our workspace, if I can. Hang on. All right, going back to the workspace, we can do this with the tick token library. So let's import tick token. Let's create an encoder. Every model has a different ways of representing tokens, so we need to find the right one. So let's say that our encoder is tick token dot encoding for model. So this is going to return the proper encoding, and our model is called text embedding ADA 002. Now that we have the proper encoder, we can translate a string of text into a list of tokens, just like we saw. So to do that, we call encoder encode. And so in our case, it's going to be doc.page content. We want to do this for every doc. So let's do this in a comprehension. So for doc in in documents, that is going to give us a list of the amount of token in each document. So let's call this doc tokens. Let's take a look at what doc tokens look like. We should be getting an output here. That's interesting. All right, seems like we have a broken workspace somehow. Let's see if we can fix that. In the meantime, I'm going to continue with this code. So we'll calculate the sum of all these tokens. So you'll have to believe me, inside of this is a list of the amount of tokens per document. So to get the sum, we are going to do total tokens equal sum of doc tokens. And finally, we can calculate a cost. So the cost is going to be the amount of tokens, the total amount of tokens of all our documents, divided by 1,000. And we want to multiply that by the cost of 1,000 tokens. And finally, let's print total tokens. We're going to have total tokens costs. It's going to be costs, and let's formatted nicely. All right, let's see if this is going to work now. Okay. So we have an issue here. Of course, here, this is actually going to return a list of all the tokens. So very much what we saw in the tokens page. So we just want the length of this. We want to know how many tokens. We're not interested in each token itself. We are interested into how many there are. And there we go. We have 1.5 million tokens, and the total cost of embedding is going to be 60 cents. So this is how you can calculate the how much it's going to cost. It's always about counting tokens. And always be sure to select the proper encoder for the model that you're targeting. All right, so we feel confident. We can now move to embed the documents. To recap where we are, right now, we are just at this step. We haven't yet embed and got the vectors and put them in an index. That's what we're going to do right now. So for this, we are going to use Chroma and the OpenAI embeddings. So we will first import Chroma. So we are not actually importing Chroma directly. We are importing the Chroma vector store of LangChain. So it is an abstraction around Chroma. What's nice is they have made all their vector store abstraction the same. They all have the same interface, or at least sufficiently, so that you can switch them out. So you could be trying others just by changing the import. We're going to import Chroma. So it's Chroma with a capital C. Oops, it's actually from LangChain.vector stores. Next, we need to import from LangChain.embeddings.openai. We want to import the OpenAI embeddings. We are going to create our embedding function. So let's call it embedding function. And we call the OpenAI embedding constructor. And here you could be passing another model name if you wanted. But for this example, we are going to stick with the default, which is ADA v2. And now, in a single line, we're going to do all the rest. We're going to get a DB by calling Chroma from documents. We have documents already. We are going to pass our documents, those that are sliced into small pieces. We'll also pass the embedding function, because this thing is actually going to take all your documents and for each call the embedding function and then store the embedding, the vector in the database. And last but not least, we are going to pass persist directory. And we just need to give it a name, the folder name that we want to use. I'm going to use my embeddings. And note that here you have a Chroma data LangChain docs, which contains the result of this operation. So if you do not wish to spend the money on right now to embed all of this, you can just use the next step here, which is just going to create the database out of these embeddings that already exist. And last, we want to make sure to persist to disk. Let's run this. Interestingly, it's going to go faster than loading all the documents from the disk. Loading all documents from disk and removing HTML takes about 2 minutes. This should take about 45 seconds. So if you do not wish to run this, simply go over the alternative here. The code is already filled in. It's the same code. The only thing that changes is how we create Chroma. We are just going to call Chroma, the Chroma constructor, pass the persist directory that already exists here, And we also need to pass it the embedding function, which is the same that we have created before. All right, so this is still running. This, how long it takes depends on how loaded the and how much under pressure the OpenAI API is. Seems to be okay today. Okay, we now have a database. So let's see how to query it. So we're going to query the vector database. As I said, the only thing we're interested in is finding things that are close. So there is no SQL, no nothing. We are just giving a string and we are getting back documents that are close, semantically speaking. So let's do result equals db.similarity search. And we are going to use similarity search with score because we want to take a peek at the scores. And the query that we are going to send here, typically that's going to be the question that the user is asking. So let's go with, for example, how do I load data from Wikipedia? And we're going to print these results. The results are a list of tuples. So we can go with a loop for duck and score in results with an S. We're going to print the score and the actual document. So we can take a look at what is in there and a nice line. All right. So here we get a first document with a score of 0.2. It is a distance. So it's the distance between the query vector and this specific document. The smaller it is, the closer it is. So the better it is. And indeed, it seems to be text talking about Wikipedia. We have another one here, still talking about Wikipedia. By default, I think this returns 4 or 5 documents. Obviously, you can change this. Take a look at the doc of the database. It is indeed returning things where there seems to be code related to Wikipedia. So this seems to be working. So this is how simple it is to query a vector database if the only thing you're interested in is retrieving similar documents. As I said before, some vector database have a lot of other features on top. Some are a mix of a vector database and a regular database where you could actually have a where clause. So you could do filtering, all these kind of things. Here we are keeping it simple. And we're getting to the last piece, putting it all together. So let's recap the pieces that we have. We have done the indexing part. We took our content library, we sliced it into smaller pieces. We went with whatever, small slices. It surprisingly works. Each of them went through the OpenAI embedding. We got vectors and put it in the index. And now we're about to do this. Get the user query, embed it in the same way. So we get a query vector. Go and look for similar vectors in the database, retrieve the text, and finally pass these texts to the final prompt. Happily, once again, LangChain is on our side, and this whole thing is going to be very easy to do in code. So we are going to put our question in a variable, and we are going to perform a similarity search. This time, we don't really care about the scores. We just want to pass whatever comes out to GPT. What's interesting is even if this search yielded results that are not very much related to the question, GPT should be smart enough to ignore them and answer using only those that are actually relevant. Next, we're going to make a template. So this is the final prompt. This is a prompt template. So this is a piece that comes out of LangChain. A prompt template is pretty much an F string. So we are going to have placeholders here, one for context and one for question. And the prompt says, use the following pieces of context to answer the question at the end. If you don't know the answer, just say that you don't know. Don't try to make up an answer. This part is important because GPT does like to make things up. So you will have to find ways to keep it to not hallucinating. It's not the easiest thing. And then we are going to pass this context. This context, that is, if you remember our pizza example, that was the menu. For us, it's going to be all these documents that we retrieved from the database here. We put the context between these tags. These are called fences. Fences, it's any way that you can find to put fences around a section of your prompt. So here we are referring to pieces of context, and these help GPT know that, all right, we're about to start the context, and here with something that looks like a closing HTML tags, we got to the end of the context. You can use other things. You could use 3 stars, dashes. You could use pretty much anything as long as it delimitates the section. Then we pass the question. So we have our placeholder for question, and we end with helpful answer. And we are going to let GPT continue. To actually call the LLM, we are going to create a chat OpenAI object. So this is, again, a wrapper of LangChain around chat, around GPT 3.5 Turbo. This is the same that you use if you would be using GPT-4. So all of their chat models. And finally, an LLM, finally, an LLM chain. And this one is kind of poorly named. So LangChain is called LangChain because it has chains. And the idea is that you can chain multiple prompts next to each other, where you have the output of one feed the input of the next, so in a chain. Turns out that they call each link of this chain a chain too. So everything is a chain. In this case, it's not actually a chain. We are not going to make multiple calls. It's a single call. So what the LLM chain, what the QA chain here is going to be, is really just passing this prompt to this LLM and returning the result. That's all. And the way we call it is this way. QA chain is going to be a function, and we can call it with a dict, passing the 2 input variables that we have defined here, because they are in the prompt. We are going to pass the context as a string and the question as a string. So let's see how it looks like. First, we need a bunch of imports, importing prompt template, LLM chain, and chat OpenAI. Let's set up our question variable. Let's go with how do I load data from Wikipedia still. We want to query the database, so that is going to create our context docs. We do db.similarity search, and we simply pass the question. Next, we are going to create this prompt with the 2 variables, context and question. I'm going to copy paste it from here. There we go. We have a prompt template that is ready to accept 2 input variables, context and question. Next, we want to create an LLM. So an LLM object that's going to be the chat OpenAI, and we are going to pass a parameter temperature of 0. Temperature is how creative GPT is going to be. When it predicts the next token, it actually, before it chooses the next token, it has a list of the most probable tokens in order of probability that could come up. And with a temperature of 0, it's always going to choose the one that it's most sure about, the one that is most probable. With a higher temperature, it may sometimes, it's random, it may sometimes select a token that is less likely to occur. So it could still be the next one, but it's less likely. In our case, we don't want it to be very creative. We want it to keep things not creative. And last is the QA chain. And the QA chain, we create a new LLM chain, and we simply pass the LLM and our prompt that we have here. Prompt equals prompt. And we can now call the chain. So we're calling QA chain with a dict. We need 2 keys. We need the question. This one is easy enough. We pass back the question. And we need the context. For the context, we need a string. So we cannot pass our context docs because this is a list of documents. So instead, what we want really is each doc.page content. We want that for each doc in context docs. And we are going to join these. So there's going to be a list of strings. We are going to join it with a new line. So really, we are just putting each document after the previous one without any delimitation. We'll let GPT deal with it. All right, and this is going to give us our result. And finally, we can print our result, and the completion is going to be in the text key. All right, so this is putting everything together. We have our context. We are getting our documents from the database. We have our prompt template to insert that and insert the question, and finally call the chain and call GPT. Let's run this and see if it can answer. How do I load data from Wikipedia? Okay, it is answering. You can load data from Wikipedia using the Wikipedia loader or Wikipedia retriever modules. That sounds actually pretty nice. So it seems to work. Let's try another question. Let's try something a little more vague. Something I wanted to do is this chatbot can only answer one question. There is no a second question. You cannot continue the conversation because it would not remember the conversation. So there is a way to do that. Let's ask. There is a way to do that with LangChain. How can I make a chain remember previous messages? All right, let's try this. Running. You can make a chain remember previous messages by using a base memory object as its memory argument. One example of a base memory is the conversation buffer memory, etc., etc. That seems nice. We still don't see any code. Let's see if we could get a code example out of this. But show an example of adding memory to a chain. Let's see what that does. All right, so here we get an example of adding memory to a chain and then some code. That looks nice, but it's still just one piece of text that rather to have it formatted in some way, maybe in Markdown. So let's just try to change this prompt and say helpful answer formatted in Markdown. Let's see what we get. How nice is this? We have a code block here. If you know Markdown, this is how you start code and end code. So this piece here is code. And then it explains this code shows an example of adding a memory to a conversation chain. Actually, let's try this code. Let's just copy paste what it gave us. Let's run it. We have an error. Oh, it is expecting a chat. It's expecting the LLM to be called chat. For us, it's called LLM. Let's just try this again. So what it does is it creates a conversation. It says a first thing saying, what are the first three colors of a rainbow? We do not see the answer here. And oops, this is cheating. And the last return we are going to see. And indeed, we see that the last thing that this conversation is returning after we ask and the next four. So to answer this, you need to be able to remember what was the previous question. The next four colors of a rainbow are green, blue, indigo, and violet. So there you go. This is a basic chat application. We have loaded the data from the LangChain documentation. We have sliced it, put it in a database, and we can now, with the vector store, with semantic search, we can find those small snippets from our big collection of documents that apply to the question, and we can pass it to GPT through a simple prompt and let GPT answer for us using these pieces of document that we have passed. And this is how you do a basic RAG with LangChain. I'm sure there are a few questions.
There are indeed. There are a lot of questions from the audience. So I know we're kind of at time, but there are so many great questions. We are going to run probably about 10 minutes over going through all these questions because you've asked a lot of cool stuff. I would say if you have to jump now, then please do watch these on the recording later on. So next question came from, it was Alex again saying, how can we pass the context from a file rather than hard coding? So I think this is fairly early on. Do you want to go through that?
So in our first example, we simply copy pasted it in the prompt, and in the other example that we went through, we loaded it from this RTDocs folder. So actually, we loaded it from many files that were in our file system here. Were a bunch of HTML files like this. The answer to your question, if you want to use LangChain, is going to be into the document loaders. In the document loaders, you have one that is pretty useful, which is the file directory. Basically, it's a directory loader. You point it to where your files are, could be text files, empty, subtitles, whatever. As long as it's text, you can even provide a glob to filter them. You call loader.load, and all of these files are going to be turned into documents. So this is how you would load data from files that you have in a folder.
That's pretty cool that you can get the text from almost any source you like and just use the appropriate loader. Okay. Yep. All right. So next one, it's actually more of a comment from Antonio just saying that Hugging Face also has embeddings as an alternative to OpenAI. Emmanuel, I don't know whether you have an opinion on the Hugging Face ones versus OpenAI versus all the different options for embedding.
Not really an opinion, but indeed there are a bunch of them. We've been using this one, the OpenAI, but you have ones indeed from where is it, from Hugging Face? So you could be loading anyone that does that in Hugging Face. You have Azure, OpenAI, you have Cohere, a bunch of them. And again, it's going to be probably it's going to also depend on your data, because what is great with embeddings is how the concepts are going to be brought together. So in this image that I showed before, where you have this space and concepts that are related to each other are close. Now, what is related to each other? For example, if you would have a model that was trained before Trump was president, you wouldn't have so much of an association between the word Trump and president. But if it was trained after that, and it saw a lot of text, mentioning Trump and president in the same sentence, those two concepts would come closer. So again, it's going to depend on your needs, and I invite you to try these models, because it's difficult to know without testing in this field.
It does seem like a similar situation to the vector databases, where there's so much competition, so much innovation happening at the moment, that you're probably going to have to try a few things and see what works best for you.
Exactly.
Okay, so next comes from Harshit. So he's saying, back in ancient history, maybe a few years ago, we used to do embedding on words. With transformers, we can do embedding on sentences. Does it make sense to do embedding on whole paragraphs?
So that, again, is going to depend on your data and your use case. So when you slice your data into pieces, you have to remember two things. One, it's these pieces are going to be matched against your query vector. So they should be small enough that they actually match. If you are going to embed 2 pages of text where it's talking about sports and current event in some specific country, plus the latest Mac that got out there, that's a lot of concepts. So you are going to have a vector that does not represent much. It's going to be a mash. It's going to be a positive match on many things. And also, your these texts that you embed, they are going, if you are doing retrieval augmented generation, they are going to end up in a prompt at the end. And a prompt is not unlimited. You have to keep it under a certain size. So that is also something to keep in mind when you are slicing your content. You want to have semantic units. It's difficult to explain. It's not really a science, I think, at this point, more art. So you want to try it out, but it's definitely possible. I think the limit for the embedding endpoint in OpenAI is 4,000 tokens. So 4,000 tokens is a lot of text. So I've never tried to embed something that big, but if it seems to make sense for your data, try it out.
All right. So again, perhaps something you need to play around with and see test what your results are going to be like. Okay, so next question comes from Adnan, and Adnan's asking, can we use our own embeddings from previous work on our data? So I guess that's the question about, like, how do you go about reusing embeddings from one project to the next?
Interesting. So the embeddings, what is very important, you could have any embeddings in this index. The only thing that matters is that these two, the way that you embed all of your corpus and the way that you embed the query, uses the same embedding algorithm or model or whatever. As long as these two are the same, then you get something that is comparable. But what you cannot do is use embeddings made by, I don't know, Cohere or some custom model, and then use OpenAI embedding to make your query vector. That is not going to work, because you are going to be comparing apples to oranges. As long as it's the same method to embed the two, to embed your corpus and to embed your query, you're good to go.
Okay, so that just seemed like a really important thing to understand, is that
Yes.
The embedding is very much tied to the model that you then go to use to query the results. All right. Next question comes from Tony, and Tony's asking, if I'm splitting up a text file with things like diagrams and tables, how can I ensure that the metadata is passed along with those text chunks?
Very good question. So you're talking about some rich content with diagrams that are maybe images. With some luck, they are described in some sort of format. In the end, the only thing that you can embed with OpenAI embedding is text. However, there is also ways to embed images. Personally, I'm not going to talk about it because I don't know enough about it, but there are ways to embed other things than text. But most of the time, you're going to be embedding text. So if you have metadata, you just need to make sure that your loader is going to take these metadata. I would say take as much as you can, as long as it's meaningful, and output that as text, and that is going to work for things like a CSV. Actually, GPT is not that bad with CSV. It kind of understands the structure, so you could be putting a CSV as is. However, embedding a CSV, that's not going to be very useful because a CSV is indeed text. It depends what you have in there. If you just have numbers, I would say don't embed it. Maybe you could embed the headers because these have meanings. They are words. But if you have mostly numbers, embedding numbers is a bit weird because they don't carry semantic meaning. But if your CSV is made of actual words, then go ahead and embed your CSVs. I've never tried to embed a CSV, but as long as it's text and it has semantic meaning, you can embed it.
Okay. Just off the top of my head, it sounds like you might want to put the metadata just in a standard relational like SQL database, and then you have your embedding separately, and just be really careful about making sure that the two databases stay in sync.
Yes, so there is where databases are going to differ. Chroma, for example, as you've seen, it's pretty transparent. We are getting back the text. We actually never see the vectors. Other databases are only going to deal about vectors. So you will need to have some sort of key, and you will need two databases, one for your text and one for your embeddings, and you need to make sure that the two match. This is this part where once you have retrieved the vectors, you need then to retrieve the text. In our example with Chroma, it comes out of the box, but with other databases, it may not. And yeah, other databases even come with much more on top of the semantic search. Some of them will have GraphQL on top of it. Some of them will be able, as I was saying, to also filter things. So you could, for example, let's say you're embedding a Q&A document, lots of question and answers, and they have categories. You could be passing metadata, so the category as metadata with each document, with each piece of question answer, and some database, some vector database allow you to do filtering. So you could be sending one query vector and a filter saying, I just want to see those of category X, for example. I think Weaviate does that. I don't think Chroma. I'm not going to play this game. Some of them do. Please take a look.
All right, super. Okay, so next question comes from Adam saying, why were we using the ADA, so the OpenAI ADA model rather than DaVinci, which is the more powerful model?
So in where were their pricing? So we were looking specifically at embedding models. So in embedding models, you have a few of them. ADA v2 seems to be the recommended, even OpenAI recommends it because they say this is their latest model that is kind of made to replace the previous ones. Its cost, as you see, is very low, especially compared to something like DaVinci. I have not personally made a test, like what happens if you embed on the same project, but embed it with DaVinci rather than Ada V2. You will probably get different results. The biggest reason is going to be cost. And you will have to try again. It's difficult to know beforehand what the performance of these is going to be, because it varies so much based on the data that you feed to it. So in our case, it was both recommendations from OpenAI saying that it is their model that is meant to replace previous ones, and because it's very cheap.
Yeah, I think this may be a common confusion because the OpenAI system is very, very confusing. For a lot of the other tasks, so for fine tuning or text generation, then the DaVinci model is more powerful than the Ada model. But for embedding, it's Ada version 2 is the latest one that you actually want to use.
Correct. So these were embedding models. You have fine tuning models where you also have DaVinci and Ada. You have in GPT, in Struct GPT, you also have Ada, which is fast but not great, and then DaVinci, the most powerful. They are different classes of models, and in our example, we are specifically using, it's not just called Ada, it's really specifically called, where is it? Text embedding Ada. So it's not like the model that does completion that is called Ada. It's the model that does text embedding that is called Ada.
All right, super. I think we've got time for one or two more questions. All right. So, all right, let's do, this is a last question then. So this comes from Raphael, and Raphael's asking about AI agents. And so that's like the next step up.
Agents, yes, indeed. So LangChain is mostly geared towards two things, retrieval, as we've done, and agents. So agents is one whole other can of worm. An agent is basically an LLM to which you are going to give tools. So it's an LLM that is going to be able to say, all right, based on my observations, I choose to call this tool. For example, it could be searching for data on Google. It could be using a calculator because it's bad at math. It's by itself. It could be actually using a Python interpreter. All the ChatGPT plugins, they are tools that the LLM can use. When is it useful? That is a very much an open question. For example, there is AutoGPT that is pretty popular, widely popular. It's very cool to look at. It probably makes OpenAI a lot of money because it's a lot of prompts. But finding a way where agents are actually useful is still an open question. I know that, for example, at DataCamp, we are thinking of using agents to do certain things. For example, around workspace. So when it's interesting to have the LLM take an action, that's where you're going to be using an agent. But it's a difficult game because you are giving a lot of power to the LLM. It has to choose the right tool. It has to use that tool correctly. Agents tend to get into infinite loops where they try something, it doesn't work. They try it again, it doesn't work. It's very much an open question. I would direct you to AutoGPT. This is where most of the action is happening around agents.
All right, super. So just one very final question. So saying, are there any DataCamp courses on OpenAI and LangChain? So we got the Introduction to ChatGPT course is our first sort of OpenAI related course. There are so many more coming through. I think there's about half a dozen in development, like a lot of them due for release at the end of June and in July. And then there's about 10 more courses we're planning. So LangChain stuff is coming towards the end of this year. But there are many, many, many courses on AI and generative AI in particular, and developing AI applications. There is a whole curriculum on its way. Now, thank you very much for that, Emmanuel. That was really amazing, and lots of amazing questions from the audience. Before you all dash off, I would say we've got a virtual conference on June 22nd called Radar AI. You can find it on the DataCamp website, and maybe Reese can post a link as well. So datacamp.com/radar-AI. We've got 15, 16 speakers about all things AI and generative AI. Is going to be really, really exciting. A lot of big names coming along. So I'm very excited to see you all there. If you haven't registered yet, please do. It is free to attend. And yeah, please do come on. All right. So thank you once again, Emmanuel. Thank you, Reese, for moderating. Thank you to everyone who asked a question. Thank you to everyone who showed up today. It's been a real pleasure. I hope you learned a lot. See you in future webinars. Goodbye, everyone.